Hello everyone, welcome back to Mathematics. So today's video will focus on lesson 16, everything you need to know on binomial distribution. For this part, I'd like to share what are the most common questions will be asked in SPM for binomial distribution. Alright, so let's use example 2 to understand this. So the first thing when we are finding probability is not finding probability first, but determining your x. Okay, so x can be played as your point of view when you are looking at the questions. Okay, so now our point of view when we are going through example 2 is getting ones, right? We have two outcomes. Either we get one or we don't get one. So for now, our point of view is to get one, and now then we can only look at the questions. Okay, give yourself have a clear point of view first, right? So for our first question is at least 3 ones are obtained. So this one we have a lot of cases, right? So R, the number of success here, can be either 3 or can be either another value, right? So it can be confusing for some questions. So for this one, what I will do is list down all the cases first. Right, so for example, the first case is I don't get any ones at all after I toss 4 times. Or another example is I get 2 times of ones when I toss 4 times. Or another example is I get all ones when I toss 4 times. Right? So here I wouldn't consider 5 as a case lah, right? Because the maximum toss is 4. So here I would not consider 5. We have only here has 0, 1, 2, 3, 4. So in total 5 cases. So going back to question 1, at these 3 here we need to include where we get 3 and we get 4. So 2 cases in total. Alright, so here to find the probability we can write it as where x is more than or equal to 3, and then we find the probability for these 2 cases, and then we just use this formula to find the probability lah. So the values of n, p and q will be same as the previous part. The difference here is just the r. Alright, so because it depends on the value here, 3 and 4. So when we calculate, the probability will be 0.0162. The second question is not more than 3 ones are obtained, right? So this meaning we cannot exceed 3. So cannot exceed 3 means we need to calculate the probability for these 4 cases, right? So probability that x is less than or equal to 3, so these 4 cases. So it will be a bit troublesome because we are finding 4 of them, but we actually have a shortcut for it. Okay, instead of focusing on the cases that we want, why not we focus on the cases that we don't want, right? Because for all of these cases, the total probability is 1, right? So if I use this 1 and then I minus out the cases that I don't want, which is 4. So instead of finding 4 probabilities, I can reduce it to only finding 1 probability, which is 1 minus the probability that I can get 4. So here is just 1, and then I minus out using the formula here, where x equals to 4, which is same as here, then I can get my probability, which is 0.9992. And the last question is, at most 2 ones are not obtained, right? So this is where x plays a big role, because here we said that our point of view is obtain 1. It's not obtain 1, right? So for each of the case here, let's find the number of ones we did not obtain. Okay, so if let's say 0 times we didn't obtain 1, so this means 4 times we obtained not 1, right? So for example, 3 times we get 1, this means 1 time we did not get 1, right? So we can fill in the rest of it. So now if it says at most 2 ones are not obtained, so if you look at the brown color wording here, those which are not exceeding 2 would be this case, and this case. So going back to our point of view, we need to find the probability for these 3 cases, 2, 3, and 4, or meaning x is more than or equal to 2. Right? We need to find 3 probabilities. So here, px equals to 2. Okay, but here we can actually do a shortcut, because in question 1, right, we have already found the probability where x equals to 3 and x equals to 4. So later here, we can use the answer from question 1. Right? So for px equals to 2, I need to use the formula. Okay, so this cannot be avoided, but this one I can just pull 0.0162 down here. Then I can get my probability, 0.1319. And another thing I'd like to share y'all is binomial distribution is known as a discrete probability distribution. Right? So discrete here means I can find the total cases in an experiment. So for example, this one, the number of cases is 5 because 0, 1, 2, 3, 4. Right? The another type of probability distribution is called continuous probability distribution, which we will see in the next 2 videos. Right? It is also known as normal distribution. And the last question is, we need to find the minimum number of tries. Okay, minimum of number of tries meaning we need to find the value of n. Right? So it will be slightly different. It's not finding the probability, but finding the value of n. And then it says the probability of obtaining at least one once is greater than 0.95. So for this part, we can actually form a statement, and then using that statement, find the n. Alright, so probability of obtaining at least one once, we can write it as this way. Right, x is more than or equal to 1, and then greater than 0.95. So now the issue is this part. Okay, if you list down all the cases that we have, x more than or equal to 1 can be all of the values here. And we don't know where it ends because we don't know the value of n. Right? The previous questions, we know the value of n, so we can stop. But this one we couldn't because we don't know the value of n. So what we can do is use the other way around, right? Because here, as you can see, all the values are included except 0. Right? So here we can find all of the probability, which is 1, minus out the parts that I don't want. The cases that I don't want. So here I can write it as 1 minus px equals to 0. Okay, then I use this formula sub into here. So the one I move it to the other side, and this will be the result, and right side would be negative 0.05. So let's simplify the left side a bit. So this part, it will be 1. Y'all can try out lah. If you put any kind of value for n, it will always be 1. Right? And then this one will also be 1 because the power is 0. This one we have left 5 over 6 power of n. Right? Right side remains the same. Then we cut off the negative for both sides, so the sign will change from more than to less than. And then here we need to move the n to the front because we are finding the value of n. So the only way to do so is to apply log for both sides. Alright? And then to find the value of n, move this to the other side. So remember, log values where the value is less than 1, it will be negative. Right? When we move it, make sure you change from less than to more than. Alright, so put inside into calculator, you'll get 16.43. But for n, we need to find, because n is an integer, right? So we need to find the smallest integer, which is more than this number, which is 17. Right? So this means if we repeat this experiment by 17 times, the probability of obtaining at least one once would be more than 0.95. Right, so we do try 17 times to get this probability. And the second way to